Hi, this question is taken from practice exam 2024 for AP Physics C Mechanics. And you see the setup where the block is attached with a spring through a string, which is massless, whereas the spring constant is 100, which actually shows that how stiff is the spring. Okay. And this pulley must be the frictionless. Okay. Because we are not going to, yeah, you see that there's a negligible friction in the pulley, so we are not going to take any rotational effect of the pulley. Okay, currently right now you can consider that this mass is exactly is at rest. Okay, right now, and we have not released the mass, whereas the mass is 2 kilograms. So when you will release this mass, due to its weight, it will fall down with not with a it's not a free fall motion, but it will accelerate down, due to which the spring will stretch. And when the spring will stretch at some location, at some point, the spring and everything will be at rest, everything will be in equilibrium. And why is that? Because the forces will be balanced. So I will show you the next position of the block when it will come to rest again. So here, students, you see that this is now a stretched spring. So what will be the amplitude according to the question? They say which of the following is approximately equal to the amplitude of resulting motion? We have to find it. Okay, so let us now understand how the forces behave. Okay, so let's start with this. So this is the weight mg downward, and this is a force of tension. Okay, I express it with this one. This is a force of tension up. Now, the force of tension is equal to the same magnitude of force of tension here. Okay, because this is the same string, and this force of tension is applied at the both ends of the same string. Okay, it means that this mg force, which is downward, is actually countered by the force which is downward, which should be downward, and that is a spring force. Okay, so I'm showing you here. So I'm writing here spring force. Okay, so right at this moment, that spring force is equals to its weight mg. And by the way, do you notice that this mass have covered some distance from its original position? So let's call it y. Okay, because we always write the spring force in terms of x or y. So this spring force should be according to the Hooke's law, right? I can write its magnitude equals to ky. So this is ky, and that is equals to, if you if we draw the free body diagram, right? So actually the mg is countered by this force. These two are equal, right? On the system, because internal forces are balancing each other. This is the internal force of tension. These are balancing each other. Okay, so you can write mg is equals to ky, and from here you can find out the value of y. So let's find what is the value of y. So it is weight of the block divided by spring constant. You can use here the value 10 for the g, and the k is 100. So that is 0.20 meter. Okay, so it means that, dear students, it means that if you notice, that was a spring's initial position, right? And this is a spring's new position. This is actually an equilibrium position where the spring is right now. Okay, you can consider this point as a spring's equilibrium position. Okay, because right now the system is at rest. Now if you move this block a little bit further down and you release it, what will happen? This mass will execute simple harmonic motion, up down up down. Okay, so I hope I'm not making it complicated. I What I'm saying is that this is a stretch spring already. Okay, and this is what I'm saying is equilibrium position. So if you further move this block further down, let's say, okay, so then it will execute its simple harmonic motion between these two extremes. Okay, so this distance which we have calculated, this distance is 0.20 meter, which we can say it is the amplitude of the motion.